All right, chapter 2 of week 1 is all about heat. It's all about how we can heat up the earth and how we heat up the atmosphere. Let's talk about some of those concepts. The first of which you must understand, heat equals energy. When we're talking about heat, we're talking about things getting hot. They have more energy. If you start thinking that way, it will make things a little bit clearer and make things a little bit easier to understand. So when the temperature goes up, things have more energy. All right, let's talk about some more concepts. All right, so we're talking about heat. How do we transfer heat? Well, there's 3 basic ways, and these 3 basic ways apply to all sciences, apply to all facets of life. If you understand these, you'll be able to apply in everywhere, every portion of your life. So 3 basic ways. The first is conduction. Conduction is actually touching. Okay, so if you touch a hot pan, your hand will get burned because the heat, the energy conducts into your hand. The next is convection. Convection works basically by density. So if you have something less dense, then it will float to the top. Convection usually works in fluids, which we do consider, the atmosphere is considered a fluid. It works the same way that water does. So hot water below, let's use a lava lamp. A lava lamp works because as that wax on the inside is heated, it becomes less dense and it floats to the top. As it cools off, it goes back down. That's an example of convection. A hot air balloon is also an example of convection. The heat, the energy in that balloon goes up, it becomes less dense, and because it becomes less dense, it rises. Okay, so that's another heat transfer mechanism. The third is called radiation. Radiation occurs by or through what are called electromagnetic waves. Electromagnetic waves are radiation. There's different ways, there's different parts of them, there's different ways to see them, observe them. We see the visible part of the electromagnetic spectrum, but there are thousands of other wavelengths. I can't even begin to describe how many wavelengths there are of radiation all the time. We just can't always sense them with our eyes. We sense them through other methods. So those are the 3 basic methods. There is a 4th method that is a little less known and applies specifically in meteorology, and that is latent heat. Latent heat can be used as a method of heat transfer because the heat, the energy is locked up in a phase change, a chemical change of water, and because of that, if that water then basically changes locations, it's transferring heat in that case, and transferring energy. Not quite the same as conduction and convection and radiation. Each one of those is very separate from latent heat, but latent heat is that 4th kind of secret method and very important for meteorology. I would like to explore this heat transfer, those concepts, all 4 of them, actually, or excuse me, all 3 of them, and it's a little simple experiment to show you. So here I've got a cup of ice. I'm going to take an ice cube out here. Now, there's the ice cube. Okay. Now I'm going to put that ice cube on my arm. My arm, first of all, immediately feels cold. Why? Because the heat of my arm is conducting into the ice cube. Okay? Here's an important concept. Science does not recognize cold as a concept. There is only the absence of heat. Let me say that again. There is no such thing as cold. There is only the absence of heat. Okay, so heat only transfers. Cold does not transfer. So the cold is not transferring from the ice cube into my arm because of conduction. It is the heat from my arm is transferring into the ice cube, and that's why my arm is feeling cold. Okay, so that is being done through conduction because the ice cube is touching my arm. Another thing is happening here. The phase change of water is occurring. So we've got a solid, and I don't know if you can see the drips actually coming off my arm now. It's melting. So the phase change of water is occurring, and we are now releasing, I'm switching myself around here. We are actually absorbing heat because the water is absorbing heat from my arm and is turning from a solid to a liquid. So because it's taking that heat from my arm, it's storing that in the phase change from solid to liquid. So as a little thought experiment to think about. The last little concept here that we can talk about is sensible heat. Sensible heat is just a term that means you can feel it. So when we talk about sensible heat or sensible energy or sensible weather, it's weather that impacts you, weather that you can visibly observe or feel or in other ways sense. So in this case, the sensible heat here is going down in my arm because it's being used to melt the water. Alright, let's move on. Alright, so there's three main heat transfer mechanisms: conduction, convection, and radiation. That radiation heat transfer becomes very important because it is how Earth gets heated by the sun. So there's two generic names that we give radiation in terms of weather and heating. They are shortwave radiation and longwave radiation. Shortwave radiation comes from the sun, and longwave radiation comes from the Earth. So we've got that. Here's the take home, and something you need to make sure you got straight. The sun does not directly heat the atmosphere. The Earth heats the atmosphere. So the sun heats the Earth, and the Earth then heats the atmosphere. So the sun does not play a direct role in heating the atmosphere, but the Earth does. That's why shortwave radiation determines how hot the Earth is going to get, and then the longwave radiation determines how hot the atmosphere is going to get. So that's why we talk about shortwave radiation and longwave radiation. Alright, so we got that concept aside. Okay, so we've got longwave and shortwave radiation. Let's make this slightly more complicated to understand the whole issue. Since the Earth heats the atmosphere, the long-wave radiation matters much, much more in the scheme of heating up the air. So if the long-wave radiation is weak, the atmosphere is cold. If the long-wave radiation is strong, there's a lot of energy coming from it, then the atmosphere can heat up more. Why is this important? Well, greenhouse gases capture long-wave energy. They don't necessarily capture short-wave energy from the sun. So it's that interaction of the greenhouse gases with the long-wave energy coming from Earth that actually trap the energy and help us to sustain life on Earth. Alright, so that makes sense, right? The greenhouse gases, we talked about that earlier. Greenhouse effect is a very good thing. We need it to sustain life, and that is dependent upon the long-wave radiation coming from Earth. Now, that's all fine, but the amount of long-wave radiation is dependent upon how hot Earth gets, right? Which is dependent upon the amount of energy that comes from the sun. Whoa, mind blown, right? Okay, so let's put this together. Why does the amount of energy coming from the sun, or not, why does the amount of energy that hits Earth from the sun change? It is not, it is not because Earth gets closer to the sun. Okay, that is not at all the reason why. Earth is actually closest to the sun during North America's winter than it is during the summer. So the Earth does not receive more radiation from the sun because it's closer. It is only because Earth's position around the sun. Since Earth is always tilted the same way all the way around the sun, it's always tilted like this. Earth's position around the sun determines how direct the sun's rays are, and that determines how hot Earth will get. So that's why long-wave radiation coming from the Earth changes, goes up and down, and that's why the temperature, that's why we have the temperature of the atmosphere goes up and down, and that's why we have seasons.